Hello guys, welcome to yet another episode of AML Talks. So today we'll be talking about Matplotlib, which is a data visualization tool of Python. And using Matplotlib, you'll be creating any data visualization that is required for you, whether it can be a basic plot or subplotting or maybe some data analysis that you need to do. So let's work on it and we will see how how it is working out there. Okay. Hello guys, so let's dive into the code. At first we need to install Matplotlib. If you have not already installed Matplotlib in your system, so what you need to do, you need to do pip install Matplotlib. So if you're going to install in Matplotlib, then you'll have to give this exclamatory mark also. So remove this comment. So I've just removed this comment and run it out. It will install your Matplotlib. As I've already installed, so I'm not going to do that. And then we'll be importing matplotlib .pyplot as plt and numpy as np. After that, you need to do one more thing in Jupyter Notebook, that is percentage matplotlib inline, so that we need to see the plots here in Jupyter Notebook. Okay, so let's run it. Okay. So then we will move to the basic line plot. So basically what we will be doing, we'll be creating a sine wave graph. Okay, in this part we are creating some x data and y data, some random x data and random y data. So basically x data, what we are doing is we are creating 100 points between 0 to 20. Okay, in y we are just getting the sin x values. Okay, of that particular, like this is using np.sinx. Okay, to create the plot, what we need to do is we need to go to plt.figure. The first we need to do is set the figure size. So in figure size we'll be writing plt.figure. Then we need to mention the fig size. So fig size will be the, this is your length and this is the this is your length and then this is your width. Okay, so this is width will be 10th and then height will be, this is basically 10 is height and 10 is width and 4 is your width. Okay, and then we'll be in the plt.plotting part, you need to give the x and y values, whatever x and y value you need to give it. Then the color we are mentioning here is blue, and for plt.title we need to give a specific title for this particular plot. So we are giving sine wave. Let's say we'll give sine wave graph. Okay, then you need to mention your x level and y level. If you're not mentioning anything, that means it will not come anything at all. And one more thing, this plt.true, this plt.grid, basically if you want to show some grid lines in your graph, then you need to mention it, otherwise you can just remove it out. Okay, so what I will do is, let's say if I remove it first and then I run it out. So basically I'm getting a graph without grid lines. So this is the title of the graph, this is the x level and this is the y level, and in the x part we wanted 0 to 20, so 0 to 20 is there, and y level sin x value ranges from -1 to 1, so that's why it is from -1 to 1. Okay, now if you want to show the the grid, so then just remove the comment plt.grid equal to true, make it, and then run it out. So now you will see the grid lines are also available to you. Okay, so these are the grid lines, it starts from 0 comma 0 and then go on, it goes on. Okay, up to 20. Okay, so let's move to the next part. So let's try to draw multiple lines in the same graph. So now what we are trying to do is we are creating a y2, that is np.cosx, and the same we are defining the figure size. Then this is the first graph that we have already created. Plt.plot x comma y, label is sin x, and color is blue. So we are mentioning the specific color here is blue. In the previous part we have not mentioned any label, remember this part. Okay, we could have mentioned a label also here, but yeah, this is some without label also it will work, but we are trying to mention a label because this label we will show the legends there. Okay, that which color line belongs to which thing. Okay, and the next part we are drawing the cosx line. Okay, so in the cosx line we are passing the y2 value x comma y2, and the label is cosx, color is red. And then same we are giving the title, x level, y level. Here additional from the previous chart that we got was we did like a plt.legend we are providing. Okay, so that will provide you which color line is which value. Okay, and then grid is true, we'll always do, and then we'll see. So see what we have got here. We have got two waves. One is sine and this is blue one is sine, and the red one is your cosine value, and the legends are also there. If it was three lines, then the three legends will be here itself. Okay, so now let's move to something else. Okay, now so we are moving to scatter plot basically. So scatter plot is like is highly useful in regression charts and all. So you'll be having x and y values out there, and then so what we have done is we have created two random values, x scatter, y scatter, and then just passed it through. Okay, so passed it here, and then we have just plotted it out here. This alpha is basically for transparency. So one more additional thing that we have in the scatter plot, whenever you mention alpha, this alpha will be it can be in scatter or in your other part also. You can in plt.plot also you can mention alpha. That will be your transparency. If it is closer to 0, it is highly transparent. If it is closer to 1, then transparency will be less. It will be highly dense. So just let's run it. Rest of them are same thing out here. Okay, so see, this is the random scatter plot, random x and y value that is scattered here. And if you just want to just have a little bit less dense, just put 0.1, and we can see that okay, the dots are quite transparent out here. Okay, so that's it. So now let's move to the previous part. We can do something else also. What we did was in the previous graph, these two are same lines. So what we can do, we can have some dashed versions also. So let's try to customize that part again. So see, we have mentioned that plt.plot. So you can mention the color here itself. So it's y yellow, it will come as yellow dash dash, then r dash dash. So if you give two dash, that means it will be dash dash thing, and if you give only one dash, that means it will be a single line. Okay, single curve without any dash. So let's and again we have introduced a line width also. We'll show it to you. Just let's run it first, and then I'll explain everything. Okay, so see, in the red portion, yellow portion, we had two dashes. So two dashes means we'll have something like this. Okay, and one single dash means it's a connective line. Okay, then again if you want to increase the width of that line, okay, any line, just give the value line width equal to, let's say I want to increase the width of line to 4. Okay, then I'll just make it 4. Okay, now see, this is thicker than the previous one. Okay, so see, title again, we title also you can give the font size. So the padding also you can give how much you want the padding, you want to have padding here. So let's say if I make it 10 and run it, see, it is quite closer to it. The moment I give the padding 30, see, it's the now the padding is 30 here. So this is the padding part. Okay, this length from a distance from this text of this graph is the user padding. Okay, now if you want to increase the font size, let's say if you can increase it to 20 also, see, now the font size is increased. Okay, now again x level again you can give the x level value, y level value. There also you can give the font size, so currently the x level and y level is font size is 12. So let's make it, I'll make one of them as 19 and other of them 20, so that you can see the difference between them. Yeah, so see, the x is bigger and y is smaller, so you can ideally you will make both of them same. So depending upon your use case, you will just have them, both of them. Okay, so let's return make it 12 only. Okay, so again the grid line true is also given. So again the line style of grid lines, again you can mention. So if you put two dashes, that means it will be dashed part. If you just put a single dash, it will be no, it will be a straight line. Okay. Then again alpha, if you want to have a quite transparent one, then you give a alpha equal to 0.2. Otherwise this is 0.2, so that it is quite transparent as of now. So what we need to do is we will just increase this value to, let's say, 0.9, and then we will see how it is. Okay. So see, uh, now it is quite visible out there. Earlier it was not visible, that visible. Okay. And again, uh, so the next part is legend. Also you can give the font sizes there. Okay. That what is the font size of your legend. So here it is mentioned as 12. You can make it 15 also. Okay. So see, legend size has increased. So you can just, maybe you can, it's not looking that good, so you just make it 12. Okay. And the same here also, we had a width of 4, make it 2. And one more thing, you can customize the ticks values. This ticks values also you can customize. Okay. So what I have done here is you can give a font size to it. So ideally it should be same. So I just to show it to you, I've given a font size of 15 here, so it looks bigger here. And then I have also given a color to it. So if you want a color red both the sides, you just mention it here, color equal to red. That's it. And then if you wish to have the same size, let's make it 12, and then run it out to see. So both of them are red now, and then it's the size is also a little bit bigger. Okay. So this is how you can customize your plots, the title, level, and everything grid part also. And then let's move to a live example of regression, and how in regression how we will do it. So regression will have people do scatter plotting. So I've just uh, have this sample regression data that I had uploaded in my regression video. You can go and check there. Okay, it's available. So just go and check to my GitHub link. You will get this data. You can just take any data of x and y, and then just run it out there. Okay. So in regression, basically what we are doing here is we're taking this from this data frame, we're reading the data regression data.csv, then we're reading the x values and reshaping that reshaping this thing. Okay. And then we are reading the y value that is there in y, and then we are just doing the plotting part again. So again, where we can see alpha, maybe we can make it 0.9, and we'll see how the regression line looks like. Okay. So see, this is sort of the data was for regression, though that's why the x and y are in the straight line, sort of a straight line. Okay. And then one special thing that we have given here is see, in the scatter plot we have named that scatter plot also. So this thing was not there in the previous thing. So you can name the scatter plot, that what this scatter plot means for you. Okay. So that's it. And now let's move to the bar plot. So bar plot is basically you'll have certain categories out there, and you'll have certain values for that, and you want to have some bar chart. Okay. So what we have done again here, we'll mention the categories, we'll mention the values, and then we'll, at first what we'll do, we'll create the figure, PLT figure. Using PLT figure, we'll mention the figure size, and then we'll move to the what type of chart we want. We want a bar plot. So we'll in plt.bar we'll pass the categories and the values. So here we'll pass the categories and values. Then again we'll mention the plt.title, plt.x level and y level, and then show it. Okay. So see. So what has happened is we have created a simple. Let's maybe make it a little bit smaller one. 8,4. Yeah. So simple bar plot is here. So in which the categories there in X, and the values of them are there in the Y. So it's a very simple thing. And so you will have some data, and then you can group it out and then put the values also there. Okay. So let's move to subplotting. So in Matplotlib, you can create in a single thing you can create different subplots. Okay, so depending upon your use cases, so what we have done here, you need to mention access also. So the first part, see, so this access will give you it's basically when you divide it, so we are trying to make it 2 by 2 matrix sort of thing. In 2 by 2 there will be 4 subgraphs. Okay, so this zero whenever you try to have this figure, instead of one figure there will be 4 sub figure, one, there will be row, first row will have one figure, first row will have two figures, second row will have two figure, just like matrix, a simple 2 by 2 matrix. Okay, so we've given a figure size here, subplot also, and then we need to mention how many parts we are going to do. Okay, so we are trying to create 2 by 2 graph as of now. Otherwise you can make it 3 by 2 or 2 by 3, that's up to you. Okay, so this x and y we are trying to create a sine graph, so sine wave, again. So in this part, whenever you divide it into axes, so you need to mention for which axis we are giving what value. So this is the first part, the line plot will be in the first part of that subplot, so that's why we are putting it 0 0. This is the right part, so 0 1 means the second part, it will come in the first row, second column. Okay, so we are that x scatter or y scatter value that we already have, that only we are using. And bar plot again, we are having the categories and value from that bar plot. So then again it's second row, first column, and then this is second row, second column. Okay, so again x y2 value we are already having. Okay, so this tight layout is just to to adjust the spacing between the subplots, and then we'll just run the thing. So see, we are getting four category, four graphs in the same figure. So basically this is subplot 0 1 0 0 0 1, and this is 1 0, and this is 1 1. Okay, so we are just for any graph, if you wish to do some. Okay, so let's move to the other common plotting types. So first is histogram. So histogram, what we will do, we'll try to create a data of 1000 data points. So we are using random, np.random. So we are creating 1000 data points with a a mean of 0 and standard deviation of 1. So that's what we are going to create out here. So in this part, we are trying to create 50 bins. So basically, the data is divided into 50 parts, equal bins, and then we are using an alpha of 0.7 and the color is blue. The rest of them are same. So let's create it out first. So see, we are getting something like this. So instead of this thing, let's say if I just give a bin of lesser bins, on how it will look like. So now you can see that the data is little bit, the bin size is now we have only 30 things, and some of them are outliers also. So that outlier detection also we can use Matplotlib. So we'll be coming to that part also when you using the statistical things. Okay, so after histogram, let's move to pie chart. So in the pie chart part, again, so let's say if you have four, I'll just see, if you have what we need to do is we need to create a plt.figure. So that shape we need to mention here, that what would be our shape of other plt, and then we need to mention the sizes, and then corresponding labels also needs to be there. So it need not be 100, actually, so automatically it will in this part, in plt.py there is a auto percentage thing, so you can mention this percentage part out here, and it will automatically make it into percentage. Okay, so rest of them are plt title and plt so is same. So sizes and level you need to mention, and plt.py for pie charts. So you need to pass the sizes and labels out here. Okay, and then just run it. So see, what is happening is just because the addition was 100, so everything is turned into percentage. So let's say if I make it a 50, how it will look like. So see, the percentage is changed now. So every data percentage is changed. If I make it instead of this, I make it, let's say, 100 and keep it 40 and add another one. Then yeah, see. So basically this is 50% and rest of them are like accordingly shifted. So this is how you can create a pie chart in Matplotlib. So to save a next we'll move to the saving the plots. So let's say if you want to save any particular plot, okay, so this is my sine wave XY data that we have. So let's we'll save it out and we can save to anything. Uh, so so this was my sine wave. So if you do plt.savefig, it will save in your current folder wherever you are using. So my current folder is here. So it's like myplot.png. Yeah, myplot.png is already saved here. This is myplot.png. Okay. So this is how it will be.